Okay, welcome to the fourth video in our Algebraic Equations series. In this video we're going to be looking at equations that have fractions. More than one fraction. Okay, so it's going to be kind of new. It's going to be a little bit different here. So if you remember back in the second video, I gave you a very brief, very small introduction to equations that had fractions. In fact, in that video there were one-step equations that were either solved by doing a multiplication or by doing a division. And so there was like a fraction and we had to multiply to get rid of the fraction. But when we did that, we had the answer. That was the end of the equation. And let's see here. In the third video, if you remember, we would have to simplify by grouping. You know, we add a term to this side, add a term, or subtract a term to the other side. Basically to get all the terms with x on one side and all the terms that don't have x or variables on the other side. And then usually, at least in the third video, they were all like this. There was a number multiplied to x equal to some other value. And then the last step was to divide. And that would isolate the x. And we divide to both sides, right? We divide that number that was multiplied with the x to both sides to get x isolated. And then obviously that's the answer. X is equal to blah blah. Okay, well, we're still going to be doing basically the same thing. However, now when we have fractions or multiple fractions in one equation, we have to do a multiplication first. And that's where it's kind of strange. I think it's kind of, we're not used to that. You know, we're used to doing a multiplication or a division, typically divisions at the end as our last step. So this is where it kind of changes. We're going to be doing a multiplication at the beginning in order to eliminate the fractions, okay? And this is where what we do to one side, we have to do to the other side becomes very detailed and very important. I got to sneeze. Ah, strawberries, strawberries. Okay, I think it's gone. I don't know. It works for me, okay? I say strawberries. Anyway, okay. So now that we're going to be multiplying first both sides of the equation, you got to understand what sides of the equation actually means. So imagine you have 3 terms on this side and 2 terms on this side, okay? And let's say they have fractions in them, at least 1 or 2, right? To eliminate the fractions, you have to multiply. And I'll get into more details about that. We're going to be multiplying by the lowest common multiple, but I'll get to that in a second. But what I want you to focus on is that we're multiplying to both sides. When I say sides, this side has 2 terms. I have to multiply, let's say, I don't know, by 3. I have to multiply 3 to both terms. This side has more than 1 term. This is where it's a little bit different. You know, in the third video, we do that division at the end to both sides, but each side was already simplified and it only had 1 term. So it doesn't feel like you're doing it to more than one thing. Now we're going to be multiplying, like, again, let's say we had to multiply 3 to both terms on this side, and then what you do to one side, you have to do to the other side. So this side had, what did I say, 3 terms? You're going to multiply that 3 to every single term. So that way you can say, I multiplied this entire side, all 3 terms on this side, by 3, okay? So this is where it gets a little strange, I think, for some people. Now, with that being said, let's move on to what I have here on the board. So to eliminate the fractions, we have to multiply both sides, and again, both sides means all the terms on both sides, by the lowest common multiple. Now, if you remember back, when did we do it? Back in the day when we were doing addition and subtraction of fractions, we had to find a common denominator. In fact, I called it the lowest common denominator. Well, it just so happens that it's the same thing as the lowest common multiple. So you have to find the lowest common denominator or the lowest common multiple, and whatever that number is, you're going to multiply both sides by that number, okay? So you might want to go back and see how we did that. I'll review it again here, I'm sure. So anyway, the lowest common multiples are found in the denominators. So you have to look at all the denominators and then find a number that's common for all of them. Okay, and that will be your lowest common multiple or lowest common denominator when you're adding and subtracting fractions. But anyway, moving on. Okay, so I'll put up the first example that I have. It's x over 2 is equal to 6. My first step, I try to always do that, put the line. Now this is an example very similar, probably even the same one from the second video of this series. This is a one-step equation or one-step problem. And you solve it by multiplying, right? So in this one, it's easy to see that the lowest common multiple is 2. Again, like I said, the lowest common multiples are found in the denominators. So there's only one denominator, so that is my lowest common multiple. So I'll multiply both sides by 2, right? So we'll multiply this one by 2, and we'll multiply this one by 2. Again, the point there means multiplication, okay? Now, if you remember back to the video of multiplying and dividing fractions, I said that if you're going to multiply two amounts, and one of the two amounts is in a fraction form, everything that you're multiplying now has to be in a fraction form. So we got to turn this whole number into a fraction. And that's easy enough. We just put it over 1. Boom. There it is. Because, well, remember that 2 divided by 1 is still 2. We're not really changing the amount. We're just changing its form. Okay. So, again, back to that video of multiplying fractions. You can go back and check it out. These two will cancel out, okay, because we're basically reducing both of them by 2. We're dividing both of them by 2. So 2 divided by 1 by itself is 1, and 2 divided by itself again is also 1. So 1 times x is x, and 1 times 1 is 1. X divided by 1 is x, so we don't really need the fraction anymore. Okay, I've already talked about that before. So we have x is equal to 12, right? When I do the multiplication over here with the 6 times 2. So that's easy, right? I mean, that's not too complicated, I hope, at this point. Let's change it up a little bit. I'll get rid of that. I'll leave that. Okay, now I'm going to add another fraction to this. I'm going to put, what if I did this? X over 4 plus x over 2 is equal to 6. How would you do that? Well, this is where we have to find a lowest common multiple that is going to be common for both the 4 and the 6. Okay? So, I'm sorry, the 4 and the 2. I was looking at it in the never mind. The 4 and the 2. We have to find the lowest common multiple for the 4 and the 2. How do we do that? Well, if you go back to the video when I was adding and subtracting fractions, I told you. And again, ideally you want to be able to do this, just by looking at it. You got to know your times tables very good, very well. Anyway, you take both numbers, the 2 and the 4, and then you're going to count by each number. So 2, 4, 6, 8, etc., right? And then you do the same thing with the other number, 4, 8, 12, 16. And then you find the first number that is common in both sequences of numbers. And I hope that all of you guys can see that it's going to be 4. Again, there's more. You could use 8, you could use 16, you could use other ones, but you want the lowest ones. That way you're not multiplying by such a big number, right? Okay. So our lowest common multiple is 4. All right. Again, I'm not going to be doing that all the time, but that's kind of how you have to get to the answer. If you can do it because you have strong skills in your multiplication table, multiplications, then you can do that mentally, and that's the ideal. So I have to multiply everything basically by 4. Both sides of the equation have to be multiplied by 4. I'm going to go ahead and separate this a little bit to give me a little bit more room. Okay, so I'll use another color here. Let's see, does this marker work? Yes. All right, so I got to multiply both by 4. Again, I'm going to put it automatically in a fraction form, and I already explained why, right? So this is going to be times 4. 4 over 1, that's 4. And this one's going to be multiplied by 4 as well. I have to cancel, okay? And I might as well write what I have to do over here to this side too. So again, we're multiplying both sides by 4, but remember that this side has 2 terms, and I have to do that multiplication with every single term on this side of the equal sign. Okay? So let's see here. Over here, these ones completely cancel out. right? 4 divided by 4 is 1. 4 divided by 4 is 1. 1 times x is x. 1 times 1 is 1, but I don't need that, okay? Because x divided by 1 is x. So all that kind of eliminates, just leaving x alone there. So plus, and then I got to do the same thing over here, but these ones don't just give me x. There's a number left over. So let's see here. I can divide both of these numbers, the 4 and the 2, by 2. 2 divided by 2 is 1. 4 divided by the same number, 2. 4 divided by 2 is 2. Okay? And then I can go ahead and do my multiplication with, just straight across. 2 times x is 2x. Okay, remember, I don't know what x is, but I can still show the multiplication by just writing them together, okay? So this says I multiplied it. I don't know what it is, but there it is. They're multiplied, okay? 1 times 1, again, is 1, but I don't need the 1 in the denominator because 2x divided by 1 is 2x. All right, so ta-da, we got rid of, and then we got rid of the fractions over here. We have 2 terms that have x. That's it. Okay? So 6 times 4 is 24. All right. These are like terms. Now this equation looks very much, and I forgot my line again, didn't I? This equation is very much like the equations that we did in the third video, right? So let's just go ahead and group these two terms, these two like terms together. X plus 2x is 3x. And then the last step is to divide, right? Divide by 3 to undo the multiplication, right? That's 3 times x. So opposite or inverse operation is to divide. And we get x isolated totally. X is equal to 8. That's a horrible 8. All right, so this was our answer. X is equal to 8. Okay? Cool. So again, lowest common multiple. To do that, we have to look at the denominators and use our multiplication skills to figure out what's going to be the same number or the common multiple for both numbers or for both fractions, at least in this example. All right, so let's go on to the next one. And my next example. All right, we have x over 3. And I'm going to go ahead and give myself some room, okay? So it's plus, and I'll just put the other one a little bit further away. Is equal to, I'll put my line right away because I'll forget, 6. Okay. So again, this is very much like the last one. This numerator looks a little bit different, I guess, right? But I want to get rid of the fractions. To do that, I'm going to be looking at these denominators, all right? So when I look at the denominators, can you guys tell me, no, of course you can't tell me, you guys are in computer world, YouTube land, but what's going to be the lowest common multiple for 3 and 5? I'll do it one more time by hand, okay, I'll show you one more time. Take both numbers and you just count out, if you can't do it mentally, 6, 9, 12, 15, 18, okay? I think that's enough. If we count by 5, 5, 10, 15, 20, right? So the first one that's common for both is 15. So that means that I have to multiply this side by 15 and that side by 15. Okay, remember that this side has 2 terms, so that means I have to multiply both terms by 15 and then the 6 also by 15. Okay? All right, so lowest common multiple. All right. So by 15, I'll go ahead and put it in blue. My little dot there. And again, it has to be in fraction form, okay? Just put it over 1. All right, and I might as well go ahead and write it over here too. Put that with parentheses to show the multiplication. All right. So I got to cancel. I have to cancel, cross cancel. If you don't know how to do that, go back to the multiplication video, right, of fractions. So I'll just do this one. So these two are going to be divided by 3, by this denominator. 3 divided by 3 is 1. 15 divided by 3 is 5. And now I can do my little multiplication here. 5 times x, right, is 5x. 1 times 1 is 1. I'm not going to put that because 5x over 1 is still 5x. And then I do the same thing over here. I can go ahead and bring down my addition sign. I'm going to divide both these ones by the 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Okay? Now I can do my multiplication. This is kind of cool. So how do I do that? Well, my denominator is 1, so I know I'm not going to put the 1 on the denominator. I might as well just bring this down to show you. So I have a 3 multiplied by this amount. So that multiplication, I'm going to show it like this, okay, with parentheses. And it's x minus 2. So this is a distributive property thing, right, where we have to multiply the 3 times the x and 3 times negative 2, etc. I'll go ahead and I'll go ahead and do the multiplication. 6 times 15 is 90. Okay, I believe, pretty sure. All right, so anyway, the big thing that we did really is we got rid of the fractions, okay? We multiplied all the terms in the equation by the lowest common multiple, okay? And to do that, we had to look at the denominators, the 3 and the 5. What number can the 3 and the 5 both go into evenly, right? And the first number that they do that is 15. Okay, so I'm going to go ahead and do the distributive property. So just remember, okay, this point here means multiplication. So we're going to multiply the 3 times all of this. And I just expressed it like this with the distributive property with parentheses. It's more, I don't know, it looks more natural, I guess. Anyway, at least to me. So let's go ahead and, I like drawing my little arrow thingies. And 3 times x is 3x. 3 times negative 2. Okay, remember, we're multiplying. We have to keep the signs under control, right? So this is a positive 3 times a negative 2. Positive times a negative is a negative, so 3 times 2 is 6, so it's negative 6, okay? Remember that you're not going to bring down this negative sign. That's not what we're doing. This negative down here is because we multiplied the 2 different signs, okay? Very important. And I'll go ahead and bring down my 5x, rewrite the 90 on the other side, okay? Now I have 2 like terms. I can group those together. Okay? And I still have, out of the 3 terms left, all my x's are grouped together on the left side, but I got to get my negative 6 over there to the other one because those 2 are the like terms. And negative 6 and 90, they can be grouped together. Remember, you guys saw this in the 3rd video, right? I want to group all the numbers that don't have x on one side and all the numbers that have x on the other side. Okay, so we're going to add. Remember, opposite operations, right? We're grouping still, so grouping is going to be an addition or subtraction. And if it's a subtraction, if it's a negative here, we're going to add, right? We're going to do the inverse operation. So, add 6 over here, that will eliminate, that will basically give me 0, right? So, but when I do it over here, I got to do it over there. So, that's a sorry 6. All right. So, 90 plus 6 is 96. Can you guys see that? I don't think you guys can. Yeah, wow. Holy cow, you guys can't see that. I'm going to write it just a little bit higher. Okay. And then my 8x. Remember, I'm just bringing this down. This eliminated. So 8x is equal to 96. I'm trying to see how much room I have. And I got to separate these 2 by dividing because right here they're multiplied. The inverse operation or the opposite operation is division. Okay, so that will leave me with x. How much room do I have? Do I have room? I don't even have room anymore. Where can I put that? You know, I'll do it over here. I'll just move it over here to the side here. 8x is equal to 96. That's what we had, right? So I'm dividing both sides by 8x or by 8. That will leave me with x is equal to 12. I apologize for, wow, that was horrible. I apologize for me running out of room, but I think you guys can get the gist. Of course, the main part of this is getting rid of the fractions. I think at this point, at this level, this is very much like the, well, even at this level, this blue line here, it's very much like the 3rd video. We did examples like this. So I'm not too worried about you guys getting it from here down. I'm really concerned, what I'm really trying to get across to you in this video is how to get rid of those fractions, okay? All right. Let's do another one. Okay. X over 2 minus 5, actually I should give myself more room because I know I'm going to have to multiply. Minus 5x is equal over 5x over 6 is equal to 1/9. And again, I should probably move that over a little bit too. Okay, now you'll see that we have fractions on both sides of the equal sign. Well, that doesn't change anything, okay? That just means we have to include the 9 when we're looking for a lowest common multiple. So now I have 3 numbers that I have to figure out a lowest common multiple for. Okay, can you guys see what it is? We have a 2, a 6, and a 9. What number will the 2, the 6, and the 9 go into evenly? The number is 18. So it's 18. All right, so I'll put it here in blue. And remember, if you don't know how to, if you can't do that, take all 3 numbers and count out, get the whole number and count out by 2, 4, 6, 8, 10, etc. Count by 6, 6, 12, 18, 24. Yeah. And then count by 9, 9, 18, 9 times 3, 27, stuff like that. Okay? And then you'll find the one that's common for all 3 sequences. All right, so 18, that's going to be our lowest common multiple. And what I do to one side, I have to multiply this whole side by 18. I've got to multiply that side by 18 as well. Okay. So once I have my 18 ready to multiply, I'm going to cross cancel. And basically what you're going to do is you're going to cancel out, divide all of them by these denominators to get rid of them. So the 18 and the 2 are going to be divided by 2. 2 divided by 2 is 1. 18 divided by 2 is 9. Okay. Well, I'll just write that. So then when I do the multiplication, I get 9x. Right? 1 times 1 over 1. Don't put that down. You don't need the 1 in the denominator. Okay. We're going to divide these two, the 18 and the 6, by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. Okay. 3 times 5x is 15x. 3 times 5, so that's what you're doing. 3 times 5 is 15. I'll bring down this negative here. Okay. All right. We're good. Are we solid? Good. Now we're going to cancel these two out by 9 divided by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. 2 times 1 is 2. Like that. Okay? That's really what I'm trying to get across here. Okay? I just want to show you guys how to get rid of the fractions. Because this is just like the last video that I did. But we'll go ahead and keep going here. So, okay, this is a positive, this is a negative. I'm going to group them together because they're like terms. They both have an x, right? And let's see, positive 9 minus 15, that's negative. Well, the bigger one's going to win the sign, so it's going to be negative. And I'm basically going to subtract them. 6x, okay, negative 6x. 15 minus 9, this is 6, okay. All right, and equal to 2. Last step is to divide, to separate the multiplication, to undo the multiplication. Negative 6 times x, right? So we're going to divide it out. Remember, you want to divide by the same sign and the same number, always, okay? Okay, so these ones cancel out. It leaves me with a positive x. I can put the sign if I want. And over here I have a positive 2, but what I do to one side, I've got to do to the other side. So I'm going to divide this side by also a negative 6. Okay? And keep in mind, your sign, this is where students always make the small mistakes. Small mistake is the same as a big mistake in algebra. You'll get the answer wrong. That's just the way it is. So anyway, you can't afford a small mistake in algebra. So positive 2 divided by negative 6. Well, it's going to be a fraction. I guess I can focus on the sign first. So positive divided by a negative is a negative. Okay, and I still have my fraction bar because this is going to remain a fraction. And If you guys remember back in the videos when we were doing fractions, I always said your fraction, your answer has to be reduced to its lowest term, and it has to be proper. So this is a proper fraction, if you remember, right? 2 over 6, that's good. We know it's proper because the numerator is smaller than the denominator. But it can be reduced. And this is how I taught you guys how to do reduction. I pick a number that both the 2 and the 6 can be divided by, and that is 2. And it would give me 1/3. So I'll go ahead and put that back here in black. And remember that the entire amount, the whole fraction, is negative because of this division of different signs. Positive divided by negative is going to be a negative. Okay? So there we go. There's that one. X is equal to -1/3. -1/3. All right. Now I think I have one more that I want to show you all, and then I'll give you guys your little homework one that I have on the board behind me here. So this one's a little bit different. I'm just trying to find, I look on the internet, I look for problems in my books and stuff to find examples that basically try to cover as much of the spectrum as I can of these kinds of problems, these different kinds of examples that you might run across when you're doing your tests and stuff, right? I should probably move that. Okay. So, my line, I like my line. Now, this is a little bit different, right? We have this fraction over here. There's a couple of ways to do it, but because what you could do is you could say 1/2 times 5x, and then 1/2 times, what is that, 2? Right, -2. You could do that because it is like a distributive property. But who wants to multiply with a half? It's kind of, why don't we just get rid of that fraction and then not have to deal with it, right? Okay, so how do we get rid of the fraction? We need a lowest common multiple, an LCM. To do that, we have to look at the denominators. Well, there's only one fraction, so that's going to be the lowest common multiple, that 2 there in the denominator. So I'll go ahead and put it here in blue. So I'm going to multiply this whole side by 2. And then I'm going to multiply that whole side by 2. Okay. So these ones cancel out, right? 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1 is 1. So it's like I have 1 times 5x. Well, that's not hard. 1 times 5x is 5x. And then the 1 times -2, well, that's not hard either. That's -2. So what happened is that we just got rid of this fraction and moved the distributive property over to the other side with a whole number instead of a fraction. Okay. And now this is where I have to do that distributive property. Right? So 2 times 2x is 4x. 2 times +4 is a +8. Okay. Pretty cool, right? And again, I think at this point you guys can all solve this real easily. Really easy, but the trick here was just to get rid of that fraction. Man, it's so nice when we can just do that, right? And then you don't have to worry about it. It just turns into nice, easy multiplications where we don't have to really think too hard to get these answers. Okay, but now we have to group. Now I have x's on both sides of the equal sign. So if you remember in the last video, I told you all that it's a good idea to try and group the x's on the side where they'll be positive. Okay? And that's going to be the the left side over here. So let's go ahead and get the 4x over here. Goes over here, -4x. Remember, it's a positive, so I'm just doing the opposite. I'm subtracting it because I'm still grouping. Remember that grouping is always an addition or a subtraction of like terms. So that cancels out completely. 5x, +5x minus 4x is 1x, or positive x. I'll put my little positive there. I'll go ahead and rewrite it. Why not? Suggestion is something you can do is, let's do that. Let's just go ahead and do that. Let me show you something here. Now I know that I typically write every little step down, and that's not for my benefit, it's really for yours, so you guys can see exactly what I'm doing. But one thing you can do when you get a little bit more practice is move things across the equal sign in one step, or how do I say, on one line instead of rewriting everything each time you do one little thing. So I know that the 2 is going to go over there, the 4 x's came over here, so we already got the x's over here, now let's go ahead and get the 2 over there. So you can do it like in the same line, and then that one cancels out. So now all I have here is x. I already got rid of the 2. The 2 is going to go over there to that side. Okay, you see what I did? I think you can. I think you can see what I did. I'll go ahead and put my x here a little bit closer to the line. And so 8 plus 2 is 10. Okay, x is equal to 10. So again, with practice, you can do more than one thing at one time on the same, basically like the same line or the same step. Be careful not to get confused. Be careful about your signs. You know, don't mix up your signs. Don't forget the rules about when you're adding and subtracting and how they change when you're multiplying and dividing. That's where my students make all their mistakes, basically. Okay, so I'll erase this. And I'll slide over my board so you guys can pause the video. Please do. Again, I do this for your benefit, not mine. And I think it's kind of fun too. But anyway, so here's your 2 problems that I want you to try and do. Good luck. Pause the video, see what you get. All right. How did it go? How did it go? So your first one was x over 2 minus x over 5 was equal to 3. Put the line. Okay. What'd you get? What'd you get? I'm curious. So what's the first thing we have to do? When you have an equation that has more than one fraction, good idea is to get rid of the fractions. Okay, and to do that, you have to multiply all the terms in the equation, or both sides, by that lowest common multiple. And to find the lowest common multiple, you look at the denominators. So I have a 2 and I have a 5. I think to myself, what number will the 2 and the 5 both go into? Well, they both go into 10. Yeah, you can just multiply them together and you will get a common multiple, not always the lowest one though. But in this case, yeah, 2 times 5 is 10, and it just so happens that 10 is the lowest common multiple. So I'm going to multiply both sides by 10. I'll use another color. Okay, same thing over here. Well, doesn't look too good, but anyway. I think you get the idea. And what I do to one side, I got to do to the other side, so I might as well go ahead and put that right away too. Okay, that's supposed to be parentheses. Okay, so now once we have our lowest common multiple ready to multiply, the multiplication is really just a cancellation process where you're going to cancel out the denominators. So the 10 and the 2, you're going to both divide by this 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Okay? And then now 5 times x is 5x. I'll bring down my negative sign over here. And then I'm going to cancel out the 5 and the 10. So both can be divided by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 2 times x is 2x. Okay. Ooh, pretty cool, right? And obviously that's going to be 30. 3 times 10 is 30. And I will group together these two. Remember that the 5 is positive because it doesn't have a sign. If it doesn't have a sign, it means it's positive. So 5x minus 2x is 3x equal to 30. Last step is to separate the variable from the number, right? Isolate the x completely. So we have to divide to undo the multiplication. Okay, divide by the same sign and the same number, always. Leaving me with x. What I do to one side, I do to the other, right? Got to divide both sides by positive 3. So positive 30 divided by positive 3 is 10. Okay, so x is equal to 10. Is that what you got? I hope so. I hope so. All right, let's do the last one, and we'll call it a day. Thanks for watching the whole thing. Appreciate it. Okay, so this one was x minus 2 over 5. And we have plus, I'll give myself some room, x over 3 equals x over 2. Again, I'm just kind of spacing things out because I know I'm going to have to put more fractions in there to cancel stuff out. Okay, so first step for me is my line. And then I need to find the lowest common multiple. What was your lowest common multiple? It's not so obvious, really. It takes a little bit more thinking. It's actually 30. When I did it, I got 30 as my lowest common multiple. Again, if you take 5, 10, 15, 20, etc., or 5, 10, 5, 10, 15, 20, 25, 30, etc., and you do the same thing with 3, 6, 9, 12, 15, all the way out to 30 at least. And 2 takes forever because it's a small number, so 2, 4, 6, 8, 10, 12, it takes a long time to get to 30, but you will have to do that because before that, there's no number that's common for all 3. You might find one that's common for 5 and 2 when you get to 10, but 3 doesn't go into 10. And then you might get one that's good for like these two guys when you get to 6, but doesn't work for 5. Or when you get to 15, 3 times 5 are 15, but it doesn't work, right? So in this case, again, you could just multiply all 3 of them and get 30. 5 times 3 is 15. 15 times 2 is 30, and that is your lowest common multiple. Again, multiplying all the denominators will give you a multiple that works. It's just that it's not always the smallest. And if you like multiplying with big numbers, go right ahead. Try to look for the lowest one, though. Okay, I'll shut up. Let's get going here. So I said 30. Okay. And then we cancel out using the denominators as our divisor, or what we're going to use to divide out. So anyway, both of these can be divided by 5, and I want to get rid of the 5, so 30 divided by 5 is 6. Okay. Aha! This is one of those distributive property ones because I have more than one term here in the numerator. So I'll just rewrite that. I won't do that just yet. So what it says is 6 times x minus 2. Okay, and that's going to be one of those distributive property ones. I'll bring down my addition here. And to cancel these two out, divide both by 3. 3 divided by 3 is 1. 30 divided by 3 is 10. 10 times x is 10x. Okay. And now divide both by 2. 2 divided by 2 is 1. 30 divided by 2 is 15. 15 times x is 15x. So now let's go ahead and take care of this distributive property. So 6 times x is 6x. 6 times negative 2. Okay, again, we're multiplying. Take good care of those signs. Don't get them mixed up. Remember that the 6 is positive because it doesn't have a sign, right? So positive 6 times negative 2, opposite signs, gives you a negative result when you multiply or divide. So negative 12. Okay, and I'll just go ahead and bring my 10x down, bring down the 15x, why not? All right, cool. So I can group these two together on this side to simplify the left side of the equation. And so let's see here, 6 plus 15, sorry, I can do this. 6 plus 10 is 16, gosh. So we get 16x, bring down my 12. Minus 12 is equal to 15x. Now that I have x's on both sides, I always like to try to find which side will the term with x be positive when I'm done grouping them together. Should I group the 16 to the right side or should I group the 15 to the left side so that that term will be positive? What do you think? Well, it should be that the 15 comes this way. And that means we'll have to get the 12 over there to that side. And I think I might do that thing again by doing the 2 steps at the same time. I'll do it here in blue so you can see what I'm doing. So let's get the 15 over here first. 15x. And remember, because it's positive, we're going to subtract it. That will eliminate it. It is gone from the right side. But now I have to bring it over here to the left side. So it's going to do the same thing over here. Okay? Subtract them, you get x. You get 1x, or a positive x. Right? But now I'm going to go ahead and move the 12 over there to that side. In the same line, right? You can imagine this little line right here. I'm just going to go... Anyway, so positive 12, plus 12. Negative 12, plus 12. is going to be 0, so it's gone from the left side. It disappeared. But what I did on this side, I got to move it over to the other side. So I could just write it right here. All right, so x is equal to positive 12. I hope that's what you got. It was a little bit tricky. It has a big, or rather a large, lowest common multiple, but that's how you do it. So get rid of the fractions by finding the lowest common multiple. That will be your first step if you have multiple fractions. You want to get rid of those fractions probably. And be aware of those distributive property examples like this one had. You cancel out it now 6 times this quantity, this numerator. A good way to express that is putting it as a distributive property. Obviously with more practice, you'll be skipping steps and stuff. Just be careful with your signs and be careful not to forget anything. Okay? Good luck, keep practicing, and I'll see you on the flip.